Welcome back to our Databricks Journey series of videos. In today's lesson, we're going to talk about how to implement Medallion architecture. Medallion architecture is very common within the industry because it's going to provide us a structure to make sure that we have data quality through the journey of the data. In the first layer, we're going to have the bronze layer. This is going to be raw data ingestion. Basically, this is going to contain unprocessed data from source systems. It's going to preserve the data lineage with minimum transformation and typically uses delta format for ACID and guarantees some time travel capabilities. Then we have the silver layer. The silver layer, it's when the data is clean and validated and the business rule has been applied, duplicates has been removed, and it's a structure for efficient querying and downstream consumption. And then we have the gold layer. This is business-ready analytics. The data has been aggregated, feature enriched, optimized for analytics, and the purpose-built dataset for a specific use case. It's usually ready for BI tools, ML models, genies, and business consumptions. Something very important that we need to discuss is how we're going to separate these layers to enforce access control and simplify the data lifecycle management. Now we're going to talk the strategies that we can use in order to implement the Medallion architecture. We have the physical isolation and logical isolation. When you require physical isolation, it's usually because you want to have separate the storage accounts per environment or business units. This is going to help you achieve a complete infrastructure separation, independent billing and cost tracking, maximum security boundaries, ideal for regulatory compliance, and higher operational complexity. Then we have the logical isolation. This is a shared storage with a container folder level separation, and this is going to help you achieve single storage account infrastructure, isolated the external locations and permissions, simplified management and monitoring, and cost-effective for similar environments, and it's a faster implementation. The choice between physical and logical isolation is going to depend on security requirements, compliance mandates, operational complexity tolerance, and cost considerations. This is an example about the logical isolation within Azure Databricks. So we have the metastore. This is going to be one per region. And then we're going to have a single external location. This is going to be on this path that we have over here. So you see we have a BFSS, a container, a storage, dfs.core.windows.net. This is actually pointing us to a container within the Azure storage account. And this container, it's going to have all your catalogs. They're gonna be physically stored over there. So the different catalogs like Dep Bronze, Dep Silver, Dep Gold, QA Bronze, QA Silver, QA Gold, Prod are going to be stored in the same physical location. And the different workspaces can access this data, and the access and permission is going to be handled through Unity Catalog. And that's why we call it logical isolation. It's because it's still going to be separated, but just through Unity Catalog. Then we have the physical isolation. Same, we have the one metastore per region, but in this occasion, we're going to have multiple external locations. In this case, for this environment, it could be for business unit or any other way you want to isolate the data. And each container is going to have just a set of the catalogs. In this case, each of the external locations is containing different environments. Now we have the physical isolation. The physical isolation has one metastore per region. As you can see, you have 3 storage accounts over here. And in this occasion, each storage account has data for one environment. You see that the Dep workspace have access to the Dep external location, which contains the Dep Bronze, Dep Silver, and Dep Gold, following the Medallion architecture. Then the same for QA and Prod. You can see that we have independency in the external locations per layer, enforces like a maximum security.